In this video, what we're going to do is we are going to take a look at how React fits into a JavaScript single-page application, kind of a bird's eye view of where it fits in, what it does do, what it doesn't do, and compare and contrast that to a more traditional application architecture. So as you're probably aware, there's a million different ways to architect a JavaScript single-page application. But generally speaking, we can kind of break it down into the traditional MVC. And I know that there's MVVM and MVVW, model view, model whatever, basically. There's a bunch of different terms that have been coined in the last decade about how to architect a JavaScript application. Each one says, oh, this is the holy grail, blah, blah, blah. But generally speaking, all the code in a JavaScript application will fit into three categories: your model, your view, and your controller. So this diagram doesn't accurately represent every single application that has been created, but it does provide a nice abstraction of the general concepts of where your code fits in. So we can see, so we can compare this to how we would architect a React application. So again, not a complete, exhaustive sort of detailed diagram, but it will serve our purposes for most applications anyway. So basically, we start off with the user, so whoever's using your application, and he interacts with the DOM. So very straightforward. The DOM, the document object model, obviously is the elements on the page, the buttons, the links, the whatever that the user interacts with. And let's go, there's two flows here, kind of. So let's start off with the user clicking a button or something. So he clicks a button, then on the DOM, or on the page rather, then that gets sent. But you know what I'm saying when I say DOM. Clicks a button on the page, and then the DOM will fire an event to our view code, our view layer, the code that's responsible for mediating between our data and our user, or our DOM. And once the view code receives an event, it has to decide, well, what did the user mean by clicking this button? And based off of that, the view code will then send an action to the controller. Now, I say send actions. That could be anything from dispatching a command if you're using the command pattern. It could mean invoking a method directly on an object if you're using a more traditional MVC architecture, whatever. The point is that the view then tells the controller that the user wants to do something. Now the controller will then manipulate the model. So the controller, being the code that kind of mediates processes, will then manipulate our model. Our model is the code that's responsible for enforcing our business rules or business logic. And then the model, of course, will interact with the server and storage and etc., often through some sort of abstraction. The model may not necessarily know exactly what it's, the nature of an API. We might have a further layer right here of abstraction, which is perfectly fine. But anyway, the model will then interact with the server, storage, etc., enforce our business rules, do something. And then the model will then update the view. And then once the view has been told, hey, there's an update, something happened, blah, 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 the view will then update the DOM. So then we have the router over here. And the router could be anything. It could be our own routing code. And by router, I mean the piece of code that's responsible for knowing what should be on the screen at a given time. So for the most common example would be, the URL. Using the URL of the browser to determine which controllers and which views and which components or whatever to instantiate and show to the user when they visit a particular place. The router could also be responsible, for example, in a master detail flow where the user clicks a button like an item on a list, and then the details of that item show up on another panel or something like that, right? So that's our router. It could be written by us. It could be a third-party library. It doesn't matter. So anyway, so this is the basic thing. All of the code in your application can fall under one of these three categories: model, view, or controller, even if sometimes the lines are blurred, and sometimes you have model code in your controller code, or sometimes you have controller code in your view code. Generally speaking, you can take any line out of your application and fit it into one of these three categories, even if they're not separated. So this is, in general, the general architecture that applies to pretty much most applications, on most single-page applications anyway. So let's go ahead and throw React into it. Now, React is just a library. All it is it's a view library. And it doesn't really give us anything else other than a very convenient way, a very fancy way of manipulating the DOM. So you could think, well, okay, so we can just take this view box, and replace it with React, right? Replace it with the components that we write for React. And you could. You could certainly just plop React into whatever sort of application you want. It doesn't really care if it's being used in the legacy application or if you're writing a whole new greenfield application around that library. It's just a library. It's just a tool. But in general, though, when you start to see React being used, React has a tendency to kind of change the way we think about the traditional MVC architecture. So the next slide I'm going to show you guys is going to be a more idiomatic React architecture. So now you see the view is gone. There's no more view and there's no more controller, and model is in quotes. We'll get to that. So again, the user interacts with the DOM, and then the DOM fires events to React and also gets synced to by React. So let's go through the fire events first. So user interacts with the DOM fires events to React. Now this React box right here I'm considering that a black box. This isn't code that we write for React. This is the React library itself doing its own little thing. So we don't affect the code in yellow at all. It's just the physically the React library. So when the DOM sends an event to React, React has a bunch of event handling code in it and changes events a little bit, and then turns around and fires those events to components. Now, components in a React application are the view, basically, of the application. So they kind of replace the view, but they can also, in some ways, replace the controller. And we'll talk about that here in a second. So the components are the things we write for React, the classes that we write. We're going to write ES 2015 classes that represent bits of the page, physical bits of the page, like a like a search box or a list of items or a tab panel or something like that. Those are components, physical things on the page that get turned into actual DOM nodes. Quick shout out to the router. So the router is still in this example just an additional library. A React doesn't come with the router. There's no, unlike Angular 2 or Angular, for example, React has no concept of what route you're on. React is just a view library. That being said, we will be seeing an example of a third-party router, React router, that interacts with React very well and will choose which components to instantiate based off of the URL of the page. So that's why I put the router here instead of somewhere else. Yes, React does not provide a router, but the router that we will be using interacts with the components in this way. So then the components will send actions to the model. You can't see me, but I'm finger quoting. What the model is in this example is pretty much anything. Just like there's a million ways to architect a standard vanilla JavaScript application, there are a million ways to architect this model bit in a React application. And you might have heard of terms like Flux or Redux or what have you, that are all just different ways to represent the model in our application. They could be the model could be as simple as our own vanilla classes that we create, or something as complex as using a monolithic third-party library that does a million different things. But the model just represents the code that handles our business logic and also directly or indirectly interacts with the server and our storage, etc. Now, this is where things get interesting. So the DOM will fire an event to React. React will forward that event to our components. Our components will then manipulate the model through whatever means that our model is to be manipulated, either direct method calls, action dispatches, whatever, depending on what sub-architecture you're using for the model. It'll do something. The components will tell the model, hey, do this thing. And whatever the model does, ultimately, at the end of the day, all the model does in a React application is it receives events through method calls or actions or whatever, does some processing, and then sets the state on the components. So what is state? Well, in a React application, you have this concept, each component has this concept of state. And we're going to see examples of what state is in the next section where we actually build up a couple small example React applications. But The state is basically the an object that is then sent to the components, and then once the components receive that state, they get re-rendered by React. So React will say, okay, component, you received this new data. I want you to completely re-render yourself. And by re-render, we'll see kind of what that looks like on the next slide. But we'll definitely see once we start talking about JSX more examples of what I mean by render. But it's very important. Just know that. So the state gets set on the components. The components then render out into React. They render out into what's called a shadow DOM. We'll see an example of that here in the next slide. And then React will receive whatever was rendered by the components, and then it synchronizes with the DOM. So I say syncs right here. So it actually synchronizes with the DOM. What that means is it'll say, okay, this component wants this element to exist, but it doesn't exist yet, so I'm going to create it. Or this component says that this element changed an attribute on it, so I'm going to now synchronize that. So it's a very, very efficient way of manipulating the DOM. And it's a very weird, very odd way to go about it. And you will have concerns, particularly performance, but we'll address those later. They're really not as big as you think they are. But React's kind of purpose is to take whatever the components say, I want this thing here, when it renders, and then React synchronizes that with the DOM. And then once it's synchronized with the DOM, then the user sees it. So we go from user to DOM, events fire to React, fires to the components, the model does something, whatever that something is depends on your model architecture. Then the model turns around and says, hey, this data changed to the components. The React will then say, okay, so the components data changed, we need to re-render you. So they re-render the components. And then the components will tell React, I want this here and I want that there. And then React will sync it with the DOM. So it's a very high-level overview of what React is and where it fits in. So again, we have a traditional MVC architecture where we might have a lot of code in our view updating the DOM, responsible for updating the DOM. Like how much JavaScript code in a standard vanilla single-page application do you have in order to manipulate the DOM or to update the DOM? Well, all of that bit gets replaced entirely by React. React comes in and it keeps the DOM in sync for you. And that's a very high-level kind of overview of what React is. But the really cool thing about React is not necessarily that it makes DOM manipulation so trivial as to basically not exist. It changes the way we think about our components. It changes the way we think about our view and our controllers and how much code we have responsible for manipulating the DOM. Once that's not there, we're kind of introduced to a whole new paradigm. And React is so new that there's still new things coming out, new ways to think about it, like stateless components, for example, which we'll talk about as well. And it makes things very, very easy to reason about. And we'll see an example of that in the next section where we look at example applications for React. But anyway, I just wanted to show you guys where React fits in. It does not replace your model, does not replace your router. It is not Angular 2. Angular 2 is a monolithic framework that handles a lot of stuff. And if you do it the Angular 2 way, then you'll have an excellent time. React, however, is not something that you get and it's a complete thing. It is just a library. You have to kind of pick and choose other bits to make it work. You have to pick a model architecture. You have to pick a router or write your own, and so on. React doesn't provide any means of communicating with the server or local storage or anything like that, like Angular 2 does. And there's pros and cons to each approach. React would be much simpler to introduce, I think, into a existing application, because again, React is just a view library. But because of the way it changes how we write views, it makes us think different about how we architect our applications. And we're going to see examples of some really interesting ways to architect applications later in this series. But with that, I think I'm going to end this video, and we will see you guys in the next.